Here we go with number 5. Question says, a student measured the heights and arm spans, so we see height, arm span, rounded to the nearest inch, each person in a random sample of 12 high school seniors. Here's a scatter plot of arm span versus height for the 12 seniors shown. A, based on the scatter plot, describe the relationship between the arm span and the sample of seniors. Arm span and height for the sample of seniors. All right, so to me it appears that there is a moderately strong, linear relationship between height and arm span, which means, because that's what we do, which means as height increases, so does arm span. A, continue, oh, this is like underneath A. Get rid of that there. So this now says, let X represent the height in inches and let Y represent the arm span. The two scatter plots of the same data are shown. So these are exact same graphs. I mean, the scatter plots are the same. But graph 1 has this line being drawn on it, that least squared regression line, and graph 2 graphs this line. All right, just the y equals x. All right, so with that, keep that in mind. I mean, you're looking at your sheet, but then we go to the questions. That it tells us how they're going to categorize people. They can classify people into one of 3 body shape categories: square, tall rectangle, short rectangle. Square means the arm span is equal to height. Tall rectangle means arm span is less than height. And short rectangle is arm span is greater than height. All right. So what we're doing then is for which graph, 1 or 2, so you're looking at graphs 1 and 2, is the line helpful in classifying a student's body type as square, tall rectangle, or short rectangle? You know, which graph is the better graph to use? All right, so you're looking at graph 1 and graph 2. Based on how they define people as square, tall, and short rectangle, graph 2 is better. Because for square, they are on the line. Y equals X. And for and then from there you can identify people who are above the line are people like the data point. I just pick at one data point that's 60, 62. All right, the first point on the graph of graph 2 on the far left side, 60, 62. So the height is 60, the arm span is 62. So if the height or the arm span is greater than the height, the people above the line then would be short rectangles. And then you pick a point that's below the line, like 64, 62. that data point, 64 comma 62, if you're looking at your graph, where 64 is the height, 62 is the arm length, so their arm length is less than height, all right, and those would be tall rectangles, they would be below the line. The graph 1 does not allow me to identify that information because some points are above the line, below the line, or on the line, and they wouldn't necessarily fit into the categories of tall rectangles, short rectangle, and square. All right, so basically, graph 2 is the one that's most helpful. Each student, the graph demonstrates whether arm span is equal to height, arm span is greater than height, or arm span is less than height. So then we do this, we go, okay, well, how many data points are on the line? And you look at the graph for graph 2, and there's 3. Now here's where if you did B wrong, or sorry, did letter I wrong, you can still get some points for 2 if you did it right corresponding to what the graph shows. But, no, you can't. You still have to justify which ones are equal. Anyways, ignore that last statement. So square is that tall rectangle, we said. So tall rectangle are people who are arm span less than height. So arm span less than height would be the people that are below the line. So there's 1, 2, 3, 4 data points below the line. And there are 1, 2, 3, 4, 5 data points above the line. That's all you got to do for part B. Part C then asks us, using the prediction model, calculate using the best model for prediction, which is what we said is y equals x, y hat equals x. Calculate the predicted arm span for a senior with 61 inches. And then I started doing this and realized that it's talking about using the best model for prediction, not for categorizing or classifying students. So I'm not using this model. I'm using the other model because it's the best model for predicting height. What we did in part B is we talked about which graph is most helpful in classifying students, not in predicting students. So a big mistake people are going to make is they're going to do like I did, and they started using that equation when the reality is, oh no, they changed the emphasis, 11.74 plus 0.8247x. So you plug 61 in here for x, and then algebra that thing, and we get y hat equals 62.05 inches. Again, the biggest mistake that people make is what I almost did, and that is we used letter B for best model, but the reality is B was asking, again, remember, what is the question asking? It's a common thing you should do every single time. What's the question asking? B asks what graph is best or most helpful in classifying a student's body shape. It does not tell you it's good for predicting arm span. So the best model for predicting arm span is the least squared regression line, which was the line for graph 1, which is why then I use this equation, plug everything in, get my solution, and I think that's it for number 5, A, B, and C. A, B, C. Yep, that's it, folks. Well, on to the next problem.